Welcome to This Explainer. Today, we're diving straight into Chapter 6, which uses the super vibrant setting of a festival, a mela, to unpack a foundational mathematical concept, counting, grouping, and comparing numbers way past 100. We're going to look at exactly how the curriculum turns counting from this frustrating chore into a beautifully simple, visual puzzle. Let's get into it. So think about it. How do you actually count past 100 without completely losing your mind? When numbers get massive, our human brains easily get scrambled if we don't have a reliable system. And that's exactly the cognitive challenge Chapter 6 tackles, introducing strategies that literally turn overwhelming quantities into structured logic. To explore this, the text drops us right into the mela alongside Aji, Teji, and Jojo. It's this bustling, colorful fair. And if you look closely at the scene between the triangular torrens and the sweet shops, the math is just hiding right there in plain sight. By anchoring lessons in real-world scenarios like this festival, the chapter proves exactly why these counting strategies actually matter in our everyday lives. Right off the bat, the chapter starts with a quick visual test. Try to guess the number of ants crawling around in a scattered group. If you've ever asked a classroom of kids this question, you know you get wildly different answers. Why? Well, because counting a huge, unorganized mob of tiny things is just incredibly difficult. Even when those ants march in a single, really long line, our eyes still get easily confused, right? You count 1, 2, 3, and then you blink, and boom, you've completely lost your place. The teacher's notes in the text highlight this exact issue, basically using these conflicting guesses as the perfect opportunity to guide students toward a much, much better method. And the secret, as the text reveals, is grouping items into blocks of 10. Whether you're using bundles of matchsticks or visual grids, counting by tens, 10, 20, 30, is vastly faster and way more accurate than counting by ones. It gives the brain this structured, foolproof way to handle volume, which entirely shifts the mindset from linear counting to structured categorical thinking. Okay, so armed with this grouping strategy, the curriculum scales things up and introduces us to the house of hundreds. This is where those groups of 10 are stacked together, and once 10 groups of 10 are combined, a brand new milestone is reached. The text visualizes this scale perfectly using a whole lot of toffees. Imagine applying our grouping method here, counting by tens past 100, past 200, all the way until we hit 298. You can almost feel the conceptual edge of the 200s fast approaching. Add just one more toffee, and that brings the count to 299. Now, this is a totally pivotal moment in our base 10 system, with 9 ones, 9 tens, and 2 hundreds. Practically every column is bursting at the seams here. And then one more brings us to a beautifully clean reset, 300. The ones and tens drop right back to 0, and the hundreds place clicks up by 1. Grasping this specific transition, really seeing how 299 rolls over to 300 is the absolute foundational key for understanding our entire number system. The chapter reinforces this by having Jojo and Taji use number lines and tiled paths. They aren't just blindly memorizing digits, they are physically visualizing jumps. By hopping from 227 to 230 or tracking house numbers on a grid, they're actively exploring the mathematical spaces between these quantities. And this logic perfectly applies when we visit Farooq Chacha's sweet shop. Notice how expertly he organizes his ladus and Mysore pak in his trays. Instead of just a messy mountain of sweets, they're arranged in precise, countable grids. This allows him to inventory his entire stock almost instantly. The text also uses physical objects to prove the absolute magic of place value. Take Arvind Datta, who needs to pack small boxes of 10 into one big box of 100. How many actually fit? Exactly 10. This tactile representation really cements the idea that 100 isn't just some big abstract number. It's literally composed of 10 tens. Building on that place value, the chapter then asks students to compare big numbers side by side. The source text advises visualizing these numbers as physical blocks. So when looking at 321 versus 231, how exactly does the curriculum teach kids to quickly spot the larger quantity? Well, the rule is incredibly simple. Look at the hundreds place first. The text explicitly asks, do the other digits matter here? No, because 300s are inherently larger than 200s. The tens and ones are totally irrelevant at this stage. So the open alligator mouth, which represents the greater value, points firmly to 321.
But the book also throws in a tricky edge case. What happens if the hundreds are exactly the same? Take 290 versus 209, for example. They use the exact same digits, just in a different order, and both start with exactly two hundreds.
It's an easy fix. When the hundreds tie, the logic just shifts one step to the right into the tens place. As the text breaks it down, we compare 9 tens against 0 tens, and 9 tens easily wins. Even though 209 has a 9 hanging out in the ones column, place value dictates that the tens hold way more weight. So the open mouth points to 290. It's just this airtight, beautifully logical system.
You know, the real genius of this chapter isn't just in teaching kids how to arrange numbers like 67, 376, or 494 from biggest to smallest. It's in revealing that math isn't some chaotic jumble of digits. It's a highly structured, visual language of tens and hundreds hiding in plain sight at every market and festival you visit. Once you start seeing the world through the lens of place value, you really have to wonder, what other complex systems all around us could be simplified just by finding the right way to group them? Thanks for joining me on this explainer.